This video, we will be talking about series. So there are two types of series. There are telescoping series and there are geometric series. So how do we do series? So basically, the notation for this is pretty simple. We just gotta write this. And what this means is basically the sum or the sum of all or series basically. So this is an infinity right here, and then at the bottom is n equals to, could be 1 or 2, 3, or it could be 0. And we got to put the a n over here. So yeah. And if you think about it, it kind of looks like the series, it kind of looks like a E. So if you have trouble with that, you could just put like an E. And I'm sure your professor would not mind it, but just try to keep that in mind. So let's start off with telescoping series. So let's say we have a series from infinity and k equals to 1. And we get this type of problem. So how do we do this? So basically, we're going to have to use a series, of course. So we're trying to find the nth term of the sequence of partial sums, and we're going to evaluate the limits of the series to obtain the value of the series. So basically, now we have our three terms, but now we have to put in we have to plug in n for n, or k, my bad, k, and plug in k minus 1. So this would be, and we can drag this over here to make it more simpler. So this would be 1 over k minus 1. So k minus 1 is plugged into k, so this would be like that, and k minus 1 plus 3. This will be equal out to k plus 1 minus 1 over k plus 2. As you can see here, you can see that if we multiply each answer together, we're going to cut some off. So we have 1, 3 minus 1 over 4, and 1 over 4 minus 1 over 5. So 1 over 4 is negative here, and 1 over 4 is positive here. So technically, we can cross it off. And this is the same with 1 over 5 and negative 1 over 5 and positive 1 over 5. So we can cross that off. And this would be negative 1 over 6 times negative 1 times positive 1 over 6 if you add in 4 for k. So this will just cross off. And this is going to be keep going on forever and ever if you do that. So, but here we have our k and k minus 1. So we're going to cross off these ones. And we are left with just this. So when we know that 1 over k plus 1 is going to be equal to 1 over 3, and this is our final answer, and no, and this is our final, factor for this. So our an is going to be just 1 over k plus 2 minus 1 over k plus 3. And why the k plus 3 is there is because it doesn't like get like erased or anything. And our 1 over k plus 2 is just one third. So now we have our final step, and we can just plug in 1 over 3 for this, and we have negative 1 over k plus 3. And when we do this, we're going to or do the limits from n to infinity. So this would just be 1 over infinity plus 3, and that will be equal to 0. So we have 1 over 3 left. And since we have that, 1 over 3 is less than infinity, so this is going to be convergent. So this is going to be the final way to do this. So you're going to write the answer like this. So 1 over k plus 2 minus 1 over k plus 3 is 130. And this is the final answer. But you don't have to exactly write it like that. You can just do it in your own way. But whatever works, that you have the final answer, that will be just what you need. And you got to state if it's convergent or divergent while doing this. So now let's look at the geometric series. So let's say we are given a sequence or a series, and we have like some number that is equal to n, right? And we have a k as an exponent. So when you do these, there's going to be a and r. And what I mean by that is a is equal to the first term, or like the coefficient, and r is equal to the common ratio. If the r is less than 1, then immediately we know it's convergent. If the r is less than 1, then the series is going to be convergent. But if the r is greater than 1, then the series is going to be divergent. So make sure you have to remember these. So we have another equation that will help us evaluate the series to state if it's convergent or divergent. So the equation is basically a over 1 minus r, and that will give you the actual answer that you will need, not if it's convergent or divergent. So make sure to remember this equation. And now let's take a look at some examples. Alright, so here we have a series of 3 over 5 to the power of k. And immediately off the bat, we can see that the common ratio is equal to 3 over 5, and 3 over 5 is less than 1. So this is going to be convergent right off the bat. We got to put in our equation so we can just find out the actual answer. So let's rewrite it. So this will make it seem much easier. So this would be AR N. So the A in here is going to be just 1 because there's no coefficient here. So we can assume that it was going to be 1. So let's start off with this. Five over 5 minus 3 over 5. I'll make it be 2 over 5, and we can multiply the reciprocal. So this will be just 5 over 2. And this is our answer for the problem. So here we have another example. This is less than 1, so this is convergent. And our second step is just to do the equation. So the a is not going to be equal to 1 over here. The a is going to be equal to negative 2 over 3. And you're going to probably ask why. So basically, so the a is going to be equal to negative 2 over 3. So the a has to be negative 2 over 3 in this situation, because in this situation it's negative, so this should be negative 2 over 3, and this would be 3 over 3 plus 2 over 3. So this will be equal to 5 over 3, negative 2 over 3. So we're going to multiply the reciprocal of that, so this would be just 3 over 5, negative 6 over 15. And when we divide it, we can divide by 3, so negative 6 divided by 3 will be negative 2. 15 divided by 3 will be 5, and this will be our final answer, negative 2 over 5.